Hi friends, once again welcome back in our educational channel, that is Present Electronics. Friends, this is our third lecture of Basic Electricity of FYJC Electronics, and in this video lecture we are going to study band theory of elements and the effect of temperature on resistance of element. First of all, band theory. In band theory of elements, there are many energy bands, but friends, the three bands are very important, and that bands are valence band, conduction band, and forbidden band. So first of all, valence band. Valence band is the highest occupied band because there are plenty of electrons, and the band energy occupied by the valence electrons is called the valence band. The band of energy is occupied by the valence electrons. The electrons in a valence band are known as the valence electrons. So the band of energy occupied by the valence electron is called the valence band. And there are plenty of electrons. The next band is a conduction band. What is conduction band? Conduction band is normally empty. Suppose this is a valence band, this is a conduction band. The conduction band is normally empty. There are no electrons, there are no free electrons. So it is known as lowest unfilled energy band. It is a lowest unfilled energy band. And in the conduction band, the electrons can move freely. That means when the electron from valence band enters in the conduction band, the electrons are free to move. And these electrons are known as conduction electrons. So what is conduction band? The conduction band in normal condition it is empty and it is normally lowest unfilled energy band because there are no free electrons. But when the electrons from valence band enters in the conduction band, that means when the valence electrons enters in the conduction band, that electrons are known as conduction electrons, and that electrons are free to move in that conduction band. The next band, that is forbidden band. What is forbidden band? The forbidden band is also known as forbidden gap. So basically it is a gap between valence band and conduction band. Suppose this is valence band which occupies the more electrons. This is conduction band which is almost empty, and there is a gap between the conduction band and valence band, and this gap is known as forbidden gap, or this band is known as forbidden band. Now friends, the structure of bands is now going to display on your screen. First of all, we are going to study the structure of conductor. In conductors, the valence band and conduction bands are mostly overlaps. So obviously there is no band gap. So valence band occupies the more electrons. There are plenty of electrons, while the conduction band is almost empty. But as there is no energy gap, there is no band gap between the conduction band and valence band, the electrons from valence bands are free to move in conduction bands also. So in conduction band, when the electron move, the electrons are known as conduction band. And how the electrons are going to move in conduction band is now going to display on your screen. पहिले आपण ती फिगर बघूया आणि मग आपण पुढच्या सेमीकंडक्टर्स कडे जाऊया. सेमीकंडक्टर्स आपल्याला स्ट्रक्चर्स बघायचे. In conduction band, when we are applying energy, the electrons moves from conduction valence band to conduction band. That is first the structure of conductor. Now the structure of semiconductor is going to display on your screen. In semiconductor, valence band and then conduction band, and there is a band gap, and actually this band gap is very low. So very small energy required for the valence electron to cross that band gap and reach to conduction band. So in semiconductors, the conduction band and a valence band are separated by using a band gap. When energy is applied to that electrons, when the external energy, mostly in form of thermal energy, or in some cases the external electric force is applied, And when this external energy is applied to electrons, that electrons from valence band moves towards the conduction band, and that electrons now becomes free. So electrons are able to move in that conduction band. So that is the structure of semiconductor. In that semiconductor, the conduction band and valence band are separated by using the band. So the structure of semiconductor is displayed, and the how the electrons travels from valence band to conduction band, that is also displayed on your screen. The next element is our insulator. The structure of insulator is going to display on your screen. From the structure it is clear that valence band and conduction band, there is a wide gap, and the electrons from valence band are not able to cross that band energy, not able to cross that band gap. So this, in case of insulator, the conduction band is almost empty. It is almost empty. When we apply very high temperature, then only in some cases the electrons from valence band may moves towards the conduction band. But mostly in case of insulator, there are no free electrons in conduction bands. So in case of insulator, it offers very high resistance in the current conduction does not take place. That is the band theory of elements, in which there are three main bands. That is valence band, it occupies the more electrons. Then conduction band, in case of conductors, there are free electrons in conduction band which carries the current. In case of semiconductor, the energy band or the band gap between the valence band and the conduction band is very small. So when we are applying the external energy, then the electrons from that valence band crosses the band gap and reaches to conduction band, and the current conduction takes place. But in case of insulator, the band gap is very large, so electrons are not able to cross that band gap and reach to conduction band. So that is band theory. Next, this band theory is also, this band gap is also known as energy gap, because energy required to cross the electron from valence band to conduction band. So that gap acquires some energy, we require some energy. So this band gap also known as energy gap. Now we are going to study effect of temperature on the resistance band. First of all, in case of conductor, the valence band and conduction bands are overlapped with each other. This is valence band and this is conduction band. So valence band and conduction band are overlapped with each other. So there is no energy gap, there is no band gap, due to which there are more number of free electrons in conduction band. But suppose the temperature of element increases. When the temperature of element increases, the more electrons are able to move to conduction bands. And in conduction bands, now the number of electrons get increased. So there are more number of electrons. So that bands may be crowded. And that electron strikes on each other, strikes on the wall of that band, and they provide the more number of electrons. And due to which this band gets more crowded. And this electron, there are more number of electrons. This electron which increase the resistance of that material. So it will not allow the electron to cross the junction, electron to move. So when the temperature increases, there are more number of electrons available in the conduction band, and that band becomes crowded, and this electron increases the resistance. So that in case of conductor, when the temperature increases, resistance of conductor is also increases. It gives more resistance. So the resistance of conductor increases with increasing temperature. Now in case of insulator, there is a large energy gap. This is conduction band, this is valence band. In case of conductor, the conduction band and valence bands are overlapped to each other. In case of semiconductor, the band gap is very low, but in case of insulator, there is wide band gap between the conduction band and valence band. So if the high temperature is applied, if the temperature applied to that element, that is insulator, increases, it is very high, then electrons moves from valence band to conduction band, will go up to the upper band, that is conduction band, and it is not crowded because it is almost empty. There are no free electrons, so it is not crowded, and due to the less number of electrons, the conductance will increase. Obviously, conductance increases because the electrons are available, and the electrons are moved in that conduction band. So, in case of insulator, the conductance will increase with availability of free electrons. When free electrons are available, when the temperature is applied to that element, the electrons from valence band get free and move to conduction bands. So obviously the resistance of this element decreases with increase in temperature. That means in case of insulator, the resistance decreases with increase in temperature. So from this we can conclude that the resistance increases in case of conductor with increase in temperature. In conductor, when temperature increases, resistance also increases. But in case of insulator, the resistance decreases with increase in temperature. So, in a material, in an element, in a material, where the resistance increases with increase in temperature, when temperature increases, resistance also increases. Then this material is said to have positive temperature coefficient. What is positive temperature coefficient? When the resistance of material increases with increase in temperature, then this material have a positive temperature coefficient. Now, the negative temperature coefficient, it is exactly opposite of positive temperature coefficient. So, in case of negative temperature coefficient, the material, the resistance of material decreases with increase in temperature. That means when temperature increases, the resistance decreases, then this material have negative temperature coefficient. Mostly, conductor have positive temperature coefficient. That means in conductor, temperature increases, resistance also increases. So the conductor have a positive temperature coefficient, while insulator have negative temperature coefficient. Because in case of insulator, resistance decreases with increase in temperature. So in case of conductor, resistance decreases. In case of insulator, in case of conductor, resistance increases, while in case of insulator, resistance decreases with increasing temperature. Now we have to find out the expression of resistance value, how it depends upon the temperature. Let R0, that is resistance, 0 means at 0 degree. Let R0 be the resistance at 0 degree centigrade. Suppose this is conductor, the resistance of this conductor at 0 degree centigrade is known as R0. And the resistance of this conductor after a particular temperature, there is a T degree centigrade. T means the temperature that will be going to apply to this conductor, that is a T degree centigrade. And the resistance at T degree centigrade is known as RT, it's considered as RT. So RO, the resistance of conductor at 0 degree centigrade, and RT is the resistance of conductor at T degree centigrade. The increase in resistance, that is RT minus R0. RT means resistance at a particular degree centigrade, T degree centigrade. So difference, that is RT minus R0, depends upon the resistance at 0 degree centigrade. That is R0. So resistance get changed, the value of resistance get changed, and that difference RT minus R0 is directly proportional to the resistance at 0 degree centigrade. And rise in temperature, that is a T degree centigrade. So RT minus R0, that difference, RT minus R0 is directly proportional to the resistance value at 0 degree centigrade. So RT minus R0 is directly proportional to R0, that is our equation number 1, that is displayed on your screen. So therefore RT minus R0 is proportional to R0, equation number 1. The rise in resistance, that is upward and outward increases. upward rise or downward rise. That means resistance increases or decreases. And that is directly proportional to the change in temperature. That means T minus 0. T, that is temperature, and 0, that is a 0 degree centigrade. That is T minus 0. So that change in temperature, that is change in resistance, that is RT minus R0, is also directly proportional to the temperature. Therefore, the RT minus R0, that is directly proportional to temperature. That is equation number 2. From equation number 1 and equation number 2, we get that RT minus R0 is proportional to R0, that is a resistance at 0 degree centigrade, into T, that is the change in temperature. So RT minus R0 is equal to alpha R0T. What is alpha? Alpha is the proportionality constant, and this alpha is known as temperature coefficient. Temperature coefficient of that element. So it is different for the different elements, and the SI unit of that alpha is per degree centigrade. Now RT is equal to RO R0 plus R0 alpha into T. That means the equation, the third equation, we are going to solve the third equation, and we get RT is equal to R0 plus R0 alpha T. Now R0 is a common factor, so RT is equal to R0 in bracket 1 plus alpha into T. So this is our final equation, which gives the resistance value after T degree centigrade, after a particular temperature. So RT is equal to R0 1 plus alpha into T. Where alpha is positive, the value of resistance increases with increasing temperature. When alpha is positive, the value of resistance increases with increasing temperature, and when alpha is negative, the value of resistance obviously decreases with increasing temperature. And the value of alpha, that is a temperature coefficient for some elements, is first iron. In case of iron, the alpha is equal to 0.00625 per degree centigrade. While for aluminium, that temperature coefficient is 0.00435 per degree centigrade. While in case of carbon, the temperature coefficient is minus 0.0005 per degree centigrade. That means in case of carbon, it has negative temperature coefficients, while in case of aluminium and iron, so these are the metals, so the temperature coefficient is obviously positive. So friend, that is the band theory of elements and the temperature of the effect of temperature on the resistance value. In next video lecture, we are going to study the power and energy. So keep watching our video lectures. Bye, take care, see you again.